So why use folding at home? Why use distributed computing to study protein folding? Well, it's natural to use simulations to fill in the gaps, but the problem is that these simulations are extremely challenging to do. It would take a single fast computer, like the fastest PC we can get now, millions to billions of days to do the calculations of interest. But instead of waiting a million days, which was of course impossible, we could wait maybe 10 days on 100,000 processors, and which is of course very doable. So what it does is it takes something which would really be impossible to do, like waiting for a million days, make it into something that's almost routine, like waiting for 10 days.
Could you explain the protein folding process in the animation right behind you?
So what we're looking at here is one of the sort of landmark simulations from Folding at Home. It's a very long simulation. And the visualization does not show all the detail, because if I showed all the detail, you wouldn't be able to see everything. So for one thing, I've removed all the water from the visualization. There's all this water that goes into the calculation, because proteins in space aren't very interesting, but proteins in water are the way things work. But if I showed you all the water, you wouldn't be able to see everything. Also, in this protein, I've sort of colored things in different ways, that some stuff is solid and some stuff is shown in these little sticks. These things are the amino acids that come off the protein backbone. And the protein is made up of like a chain of different amino acids, and each one has a different chemical characteristic. And I'm only showing the ones that are interesting for the purpose of this movie in Spacefill. These are the ones that are hydrophobic, the ones that are aromatic in terms of chemical language. And what we're looking at here in this movie is that the protein actually did not fold so far. It's actually collapsed into something kind of random and misfolded. And in some ways, it's kind of a lot like someone who doesn't know how to parallel park, that's trying to parallel park, and that they get into the space and they're kind of stuck there. And once you're stuck, you can't really sort of just fix it. You basically have to do what you can, or basically come out of the parking spot and come back in. Once it breaks out, it's actually going to come out, and then kind of like a drunk guy trying to parallel park, he's going to try to come back in, and it's actually not going to get it right on the second time, and then come back out and come back in. And every time it does it, though, it gets something a little more right, as we see in this movie. And that actually helps it fold on its way. So right now it's still basically sitting in this first collapse state, although it's been exploring lots of different possibilities. So this is what we're seeing here, is that this is one of the first unfolding events in this part of the simulation. And it sort of came out of the parking spot and came back in, it came out again, and it's coming back in. And now it's basically trying to do things, trying to get to its folded state. And certain parts of what it's doing are right, and certain parts are wrong. And it's just trying its best to get things into the right spot. It's going to go through this actually a couple different times. And it's actually already starting to make some progress. So that interaction actually is correct. And some of this stuff, it's hard to see it on very visually, but this is actually forming an alpha helix right now. So this part's correct, and this part's correct. And actually now it's formed this triple part of the core, so that part's correct. And it just really needs to just be able to put these final pieces together, and that's when it does that. So it got each of those pieces and finally just sort of flipped around and locked in. And now it's actually basically folded. This part is actually intrinsically unstructured, so it's going to flop around like a flag. But this part of the protein is the part that's folded, and it's pretty rigidly sitting there. Unlike the rest of the movie where it's sort of moving around, here it's basically locked into the right state.
Thank you, Professor Pond.